James Claypole is at the Swansea University, and he will talk about enabling sustainable electronics through recyclable silver inks. Ink.
Can you see that?
Perfect. Perfect. Doctor, I said professor, I apologize.
I won't turn down a promotion.
You will get there, no worries. Dr. James Claypole, the stage is yours.
Thank you. I'm going to talk today about enabling sustainable electronics through our recyclable silver ink technology. So a little bit about me. I'm a research officer at the university and the Welsh Centre for Printing and Coating. I spent the last 10 years working in printing and coating research. I have a PhD in nanomaterials, which focused on the rheology of process materials. And I've worked on a number of notable projects, including the rheology of inks and formulations, wearable technology, and more lately on sustainable electronics. So the program that I'm on now is iCure Explore. So the iCure Explore program is a period of market research and determining the best route to commercialize the technology that we developed in the university. And it's looking to create impact from university research. And it's funded by Innovate UK. So the problem we're trying to address is electronic waste. So there are 57 million tons of electronic waste generated last year. This is due to an increase to 75 million tons per year by 2030. This is adding to the 347 million tons of unprocessed electronic waste already on planet Earth. And it's not just a problem for developing countries. In fact, 16.2 kilograms per capita is produced in the EU. In the UK, we produce 1.6 million tons of electronic waste, and 30,000 tons of that is illegally exported. So electronic waste can be recycled, so that's okay. In the UK, we recycle 57% of our electronic waste, but globally, less than 25% is recycled. But what really happens? What is it really recycling? So there are two approaches currently to dealing with electronic waste. So first, you take your electronic waste and it's taken to your recycling center and it's shredded into tiny little chips. It then goes down one of two processes. The pyrolytic route, in which case it is literally burned and smelted to produce lumped precious metals, or you use some pretty horrific chemicals called piranha solution to dissolve everything, and more chemicals then to precipitate out the precious metals. So that's what electronic waste recycling currently looks like. So what does it produce? So what you get out is lumped precious metals, which is the high value part and the thing that the process is all designed to get. But what it also produces is hazardous waste, various different ashes and large amounts of toxic chemicals. But there is another way. So starting at the beginning and designing new products for circularity. So this is why we started with our secret ingredient that goes into our inks and how we make them recyclable. So our not so secret ingredient is silver coated ferrite flakes. These are a core shell particle which can achieve 75% of the conductivity of silver flake inks. But it's the ferrite core that gives us the most interesting properties by making every particle magnetic. The reason we get such good conductivity is because the charge tends to travel around the outside of the particles rather than through the middle. It also makes, the ferrite core also makes these particles very cost effective due to the low volume of silver in them. So what we look to do then is we formulate an ink. Then we use the 3-mate very simple ink based around a polymer, solvent, and particulate. And the polymer and solvent can be bound to form a resin, and we use this to make our conductive ink. This means that since the technology resides within the particles, we can change the polymer resin system to a range of different applications, such as flexibility or adhesion. We rely quite heavily on ink rheology, since this is my background. So our initial tests, we made a